We're now going to start our work with chapter 3, which is using the derivative to do things. It's applying the derivative. The textbook calls it applications of the derivative. Well, what we're going to be saying is now that we know how to compute all these derivatives, the question is what can we do with them? And it turns out quite a lot. What we want to start with is, as very often happens with many topics, we need to start with a large amount of terminology. And then we're going to put that terminology together with the work that we've done so far and be able to use it to really find some fairly remarkable and very practical, very useful results that you'll use not only in mathematics, but also these are very widely usable in many fields in the sciences and social sciences and many areas of study. So, what we're talking about are something called extrema on an interval I. I think what I'm first going to talk about is talk about the interval, because I think most of us are basically familiar with intervals, but I want to specify what this means just to make sure we're all on the same page. So an interval I. So I is just the label or the symbol we're going to be using to represent an interval. The intervals may be of many different varieties. When I'm talking about something occurring on an interval, what we will be saying is a function needs to be, for example, continuous on a closed interval or differentiable on a certain type of interval. We need to know what we're talking about, so I'm going to make sure and iron that out at the very start. There are many varieties of intervals on offer. Many of the statements we're going to be using do not apply on all possible intervals. They only apply on certain varieties of the intervals. And so we need to make sure that we have clear in our mind what sort of intervals there are, what sort of intervals we're working with, what sorts of intervals these statements actually apply to, so that we can know when the calculus techniques actually do apply, and maybe sometimes more importantly, when they do not apply, and so that we don't start to do work that's not actually allowed. So, the types of intervals we could have, so I, the interval, could be, and these are all these different varieties. Well, one possible interval is the entire x-axis. And so if we're going to draw a picture of this, it would be the entire x-axis. There is no exclusion. So simply, when we write this, we typically simply write the number line, 0, 1, 2, 3, -1, -2, just the entire number line. That is one possibility when we talk about, we'll talk about extrema in just a bit. But whatever they are, they might exist on an interval. This might be an interval upon which these extrema exist. This might be an interval about which we're speaking. Other possibilities are an interval that starts at A and goes to positive infinity. That interval, if you remember from your glory days in algebra, suppose here's the value A. Remember, we do not include A. Some of you may have learned to write pictures like this. Here's A, and you'll put a parenthesis here. Or some of you may have learned to put an open circle here, and then you'll do something like this to indicate the interval. This is fine. If you use this notation, I will understand it. That's fine. That's perfect. That's great. That's wonderful. No problem. What I like to do is lift my picture off the axis, because occasionally what we will be doing is taking more than one of these and superimposing them. And if I take 3 of these and superimpose one over the other, pretty soon what you have is a mess. Whereas, if you do what I'm doing here, and this is not unique to me, I learned this from a different instructor somewhere. But if you lift it off the axis, the picture is a little bit clear. Here's one of them, here's the other, here's the other, and we might be asking, now where do all 3 of those take effect? Here, it's a disaster. Here, they all 3 take effect in that region. So Sometimes it is much more convenient, I think, to write it using this sort of way. But if you write your intervals this way, hopefully I'll be able to figure out what you're writing. All right, so that said, we could also have the interval including A. That would be something like, here's the number line, here's A. We actually include A. So remember, if you fill in the circle, that's including the point. If you do not fill in the circle, that means it is not included. And remember, what that means is that there is no smallest value in this interval, because no matter what number we pick, we could magnify and find a number between there and A. Whereas in this picture, there actually is a minimum value in the interval. It is A. And so this includes the endpoint A. This does not include the endpoint. We also have the corresponding negative infinity to B. Typically, I use A for first component and B for second component of these intervals. You can have B not being included. That would be this sort of a picture. You could have B being included. That would be that sort of a picture. And then, so these are all the various intervals of infinite length. We also could have intervals of finite length. And so there are several possibilities here. We could go from A to B, including neither endpoint. So that would be corresponding to this sort of a picture. Right? We do not include either endpoint. We could include both endpoints. That's a possibility. That would be a picture sort of like this. There's not a lick of calculus anywhere here. This is just a review of our basic terminology and notation. And then we could have do not include A, but you do include B. Is it clear what that would look like? Here's A, here's B. Do not include A, but you do include B. And then we could have yes, include A, no, do not include B. And this would be the last of our intervals. Sorry, that's an A. And that goes to B. We include A, do not include B. These are all the various types of intervals that we will consider. If you go hang around the coursework long enough, there are more things on offer than this. But for us, for now, these are the various, that would be 4, 8, 9 types of intervals. So when we say an extrema on an interval, we're talking about something like this. There is some terminology that we use. There's something called an open interval and something called a closed interval. An open interval, it's a technical term that we don't need to go into. This is an open interval, this is an open interval, this is an open interval, and this is an open interval. And then we also have something called a closed interval. This is a closed interval, this is a closed interval, and this is a closed interval. These two are neither open nor closed for a technical reason that, again, we don't need to worry about. Sometimes these are called half open intervals. A person would say, well, why aren't they called half closed? Well, it actually could go either way. It turns out, for reasons beyond the scope of our course, we tend to emphasize open. So these are half open intervals. For our purposes, anytime we say an open interval, it means it does not include the endpoints. If we say a closed interval, it means we do include the endpoints. Remember that you never, ever, it is never, ever correct in any circumstance for our purposes to put a bracket next to an infinity. These are contradictory symbols. This is never, ever, never correct. Similarly, this is never, ever correct. It is never, ever correct for our purposes to put a bracket next to the negative infinity. These are, for our purposes, contradictory symbols. If you hang around the coursework long enough, things can change. But for us, those are the restrictions that we're operating with. So this is closed interval, open interval, and so on and so on. Most of the work we're going to be doing, not all, but most of the work we're going to be doing, we're going to specify one of these two. We're going to want our intervals to be of finite length. That's not always the case. Very often we will consider intervals of this type and occasionally of these types. But most of our work we're going to be considering intervals of finite length. All right? So when I say the open interval AB, the open interval AB, we mean that collection of symbols, which means we need this set of points. If we talk about the closed interval AB, the closed interval AB, this is the closed interval AB. Open interval AB, closed interval AB. And so these other things can be specified in other ways. Open interval AB, closed interval AB, and that's going to be important for our work going forward. So that's a quick little introduction, a review of intervals, and then now that we have that, our next piece of the puzzle is going to be talking about extrema and the language that goes into that. So for now, that's sort of a quick brush through, a reminder to ourselves of intervals, and we'll get more on that in the next video.